See it okay? Alright, here we go. So this one is called simplifying and rationalizing. Okay. Simplifying and rationalizing. Sometimes I'm going to ask you to just stay with me. You don't really need to just kind of copy all the time. And I'll give you time to copy it. I want you to understand it. Here's the first example. Okay, we're going to use simplifying method for this one. All right, so we're going to simplify for this one. All right, so whenever we simplify, we usually factor. You want to use factoring. Okay, we've seen something like this before, right? But this is kind of like a review. So let's start with an easy example. Let's say limit x approaches -3 and x squared plus x minus 6 all over x plus 3. All right. So let's go back and review. All right, remember we can graph, right? Which that's pretty hard to do without a graphing calculator. So we're not going to really, we can use this, but we're not going to use that. We can graph this if you want to. We can use a table, and that's also tedious. We talked about this last week, right? We can use like negative 2.99 or negative 3.001, but we can use that, but that's just too much work. And we can also use direct substitution, but sometimes direct substitution doesn't always work out, right? So let's think about it. Can we use direct substitution for this one? Is it possible to use direct substitution? What do you think, guys? Okay, some people say no. Why is it no? Because what happens when you plug in -3 as a denominator? Isn't that -3 plus 3 that will give you 0? So that's no good, right? So direct substitution is no good for now, okay? So we're going to use simplifying method, which is factoring, which will be number 4, or number 5 will be rationalizing. We're going to go over this in a little bit, okay? After this example. All right, so we're going to concentrate on simplifying and rationalizing. That's what we're going to concentrate on today. And we also learned special trig. Did we go over special trig yet? Did we? No, not yet. All right, so we're going to go over special trig later on. All right, so there are other methods that we need to go over in this class. So far, I guess we just went over those 3 things. We're going to concentrate on those 2. Later on this week, we're going to go over special trig. Okay? All right, so here we go. So is this factorable? This example should be pretty easy. Let's go ahead and factor this out. I'm hoping that everyone knows how to factor this. So go ahead and factor this. I hope you guys are very good at factoring. Okay, how's your factoring skills? Did you get it already? Yeah? So what is it? If you factor x squared plus x minus 6, what would that be?
X plus 3 times
x plus 3 times
x minus 2.
X minus 2. All right, so there it is. All right, so again, factoring is so important in this class, all right? So learn how to factor. This factoring skills, we learned this from like many years ago, right? Okay, so why is it important to factor? What do you notice? We can cancel x plus 3 and x plus 3. So what do we have now? We have a limit. X goes to -3. What do we have? Don't we just have x minus 2? We just have that. Okay, now can we use direct substitution? That means can we directly substitute negative 3 into x? Yes. All right, so what is it if you directly substitute negative 3? So this is negative 3 minus 2 is equal to negative 5 will be your limit. There it is. All right, so first part of your homework is this. So you're going to have close to about, I think, 4 or 5 questions on simplifying. Does that make sense? That's pretty easy, right? The second part, however, is pretty difficult, all right? That part is kind of hard. All right, you guys ready for that part? Okay, here we go. All right, so anybody need more time with this? All right, we're going to move on. All right, so now this is called rationalizing. Yeah, so here's an example. Limit as x goes to 0, square root of x plus 1 minus 1 all over x. All right, so I'm not going to list out the things that we just talked about. Remember, we can use a graph, which you don't want to, right? I mean, that's, again, this is pretty hard to graph without a graphing calculator. How's it going? All right. So you're just coming in? All right. Yeah, sure. Have a seat. Sure, you want to use the ticket for bed? Okay. All right, so you guys ready? So we cannot, can we use direct substitution? No, why not again? Because if this is 0, then, all right. So when do we know when we're supposed to use rationalizing denominator or the numerator? You need to have a square root. If you have a square root, you should be thinking of using rationalizing. So here's a square root. I like to put parentheses around them. I'm going to put a parenthesis around that, around this. And we're going to multiply top and bottom by the conjugate of that. Now we need to go back and kind of define what conjugate is. Conjugate. Do you guys remember what conjugate was from integrated 3? If you have like 3 plus 2i, what is conjugate of 3 plus 2i? Anybody remember? Conjugate? Or did you study 3 plus 2i? Imaginary solutions? You guys didn't study that? No? Okay. So conjugate is just changing the middle sign. That's it. So if you have 3 plus 2i, it is 3 minus 2i. That's all you need to do. If this is a minus, you just need to change it to plus, vice versa. Does that make sense? So conjugate is pretty easy. You just need to change just the middle sign. Not everything else, just the middle sign, okay? So we are using conjugate for this one. So what is conjugate of square root of x plus 1? Minus 1. The conjugate of that will be square root of x plus 1 plus 1. And square root of x plus 1 plus 1. All right. We do need to FOIL the top, but the denominator, you kind of leave it alone, okay? So this is where you need to help me. This gets like kind of tricky and then a little bit complicated. So help me out with this. All right, so we're going to FOIL. Remember how to FOIL? So what is square root of x plus 1 times square root of x plus 1? What would that be? Isn't it square root of x plus 1 squared? Like that? All right, do you guys follow? Yes? Okay. All right, next we need to multiply to the second one. What is square root of x plus 1 plus 1 times 1? Isn't it just 1 times that? So this is just square root of x plus 1. All right, so we multiply the inner. What is negative 1 times square root of x plus 1? You're not helping me very much. Negative square root of x plus 1. Okay, how many of you guys follow so far what I just did? Okay, good. All right, so what's the last one? What is negative 1 times positive 1? Negative 1. All right, very good. All over, denominator, you just leave it alone, okay? Do not multiply it out. Now let's go ahead and try to simplify this. All right, what's square root of x plus 1 square? What happens with square root with square? What happens to those two? They cancel each other out, so we have parentheses x plus 1. What happens to this positive square root of x plus 1 and negative or minus square root of x plus 1? They cancel each other out, and then we have minus 1 all over x times square root of x plus 1 plus 1. All right, I'll give you time to copy all that. Okay, so what happens to, I'm going to take out all the parentheses out. If I take out the parentheses, I have limit x goes to 0, x plus 1 minus 1 all over x times square root of x plus 1 plus 1. All right, what happens to this positive 1 and negative 1? They cancel each other out. So we have a limit x goes to 0, x over x times square root of x plus 1 plus 1. I'll give you time to copy that. Okay, so do you notice anything after you simplify everything? What happens? Do you see this x and do you see this x? Can I cancel those? All right, so how do I know, again, if I did this correctly or not? When those things cancel out nicely, so that they cancel out nicely where we can use direct substitution towards the end. So if these two cancels out, then I get limit x goes to 0, 1 over square root of x plus 1 plus 1. Okay, now can I use direct substitution? Yes, we can use direct substitution, so that means most likely we did it correctly, because now we can use the direct substitution, and x was canceled out. I hope that makes sense, okay? So if I plug in 0, isn't this 1 over square root of 1 plus 1? What's the square root of 1? 1, so this is 1 over 1 plus 1, which is 1/2 is your limit. Okay, how many of you guys follow what I just did with that one? Okay, so I gave you time to kind of copy all of this. Later on, Mr. Cabrales is going to walk around and kind of help you with those things, okay? But, I'm going to go over one more example. I want you to kind of like not copy anything and just help me with each step, okay? Anybody need more time with this? All right. Here we go. If I can find it. Hold on a second. I'm on the wrong page, I think. Oh, I'm on the right page now, okay? Sorry about that. So this is actually number 60 from your homework problem, okay? Do not copy this yet, okay? I'll give you time to copy. Just put your pen and pencils down. All right. So you're just going to help me with this, okay? All right. So remember those things that we list them out, like some of the different methods to solve this type of question? So you should recognize that if you see square roots, then first thing you should think of is to use what? So we're going to use rationalizing. Does everyone understand why we're using rationalizing? Okay, so how do you simplify this using again, don't copy anything, just pay attention, okay? Just look. All right, so how do we use rationalizing? What do you do? Conjugate, very good. So you multiply by square root of 2 plus x minus square root of 2 over x times, what do I need to multiply the top by? Say it. Square root of 2 plus x plus square root of 2 over square root of 2 plus x plus square root of 2. All right, so help me out with the next step. All right, so when we FOIL this, all right, so remember f is the first one, so which one is the first one? Square root of 2 plus x, what? Power of 2. And then O is the outer one, so what is that? Help me. What's the outer one? Come on. Someone. Say it.
The square root of 4 plus 2x.
No. It's just square root of 2 times square root of 2 plus x. That's it. Square root of 2 times square root of 2 plus x. That's it. Okay? Again, like I said, don't copy this. Just pay attention. That should be plus. All right. What's the I? I is the inner one. So can someone help me with the I? Minus square root of 2 times. Very good. And then L, last one. Negative square root of 2 squared. Very good. That's it, guys. Okay? And then all over, do not multiply the denominator. Square root of 2 plus x plus square root of 2. Okay, so what happens with this square root and square? It cancels out, so this is limit. X goes to 0. This is just parentheses 2 plus x. What happens to the square root of 2 times square root of 2 plus x and minus square root of 2 and square root of 2 plus x? They cancel each other out. And what's left over? Minus 2, negative 2. Very good. All over x times square root of 2 plus x plus square root of 2. All right, help me. Just focus. All right, don't write. What do you notice about the top? What do you notice? Anything on the top?
We could cancel out the 2.
You can cancel out the positive 2 with negative 2. So what do you have left over then? X over x times square root of 2 plus x plus square root of 2. Do you think we did this correctly so far? Do you think we did it correctly? Why? Why? Because of the x cancels out nicely. Do you see that? So then this is limit. X goes to 0, 1 over square root of 2 plus x plus square root of 2. All right, I know that you guys learned this from integrated 3, but I know we forgot. So, all right, can we use direct substitution now? So what is it if you use direct substitution? It is 1 over square root of 2 plus square root of 2. Does anybody know what square root of 2 plus square root of 2 is equal to? 2? It's not 2. It's not just 2. What's the square root of 2 plus square root of 2? No?
Square root of 4.
It is 2 square root of 2. is 2, because this is 1 square root of 2 plus 1 square root of 2, which will give you 2 square root of 2 will be it. Now, sometimes your teacher doesn't like to have the square root of 2 in the denominator. Do you remember what your teacher did? You need to rationalize the denominator. How do you rationalize the denominator? Multiply top and bottom by square root of 2 and square root of 2. How many of you guys remember this at all? Kind of? Okay. So then this is square root of 2 over 2 square root of 4, which is square root of 2 over 4, and that'll be it. Okay? So I'll let you kind of figure that out, but you can tell that you definitely need to practice your multiplying skill. All right, before I let you guys go to work on this on your own, anybody notice the shortcut from here to there? Anybody notice the shortcut? Anybody notice the shortcut?
The square roots cancel out.
All the time. And what happens to the middle ones? What happens to the middle two terms? They cancel out. Do you know what they're called when they cancel out and then you get squares at the end and then if you have a minus? There is a special name for that. Difference of two squares. Like difference of two squares, a squared minus b squared. Have you seen those? Yeah? So it's always, if you use conjugate, it is always this one, conjugate. So basically, you don't need to show all this step. You can just square the first one, you can just square the last one, and you take the subtraction or difference between. How many of you guys understood what I just said? 3, 4 people. Okay. All right, so you can use a shortcut if you want to. You don't need to. If you want to show all the steps, go ahead and show all the steps. All right, so let's go to your Canvas and work on those questions. Let's see how much you can finish in class. Can you pause it? That's perfect timing. Oh my gosh.